In version 60 of its SDKs for Unity and native code, Meta has released a new version of its face tracking OpenXR extension, which now includes how far stuck out your tongue is. Introduction to Virtual Reality and Quest Pro. Virtual reality is a computer-generated simulation of an environment that can be interacted with in a seemingly real or physical way. VR systems typically involve the use of a headset that provides a three-dimensional, immersive experience. The Quest Pro is likely an iteration or a model extension of the Oculus Quest, a popular VR headset developed by Oculus, a subsidiary of Meta, formerly Facebook. The evolution of VR input. One of the critical aspects of an immersive VR experience is the input method. Initially, VR relied on handheld controllers to track hand movements and interactions within the virtual environment. Over time, there has been a push towards more natural and intuitive ways of interacting with the virtual world. This has led to the development of technologies like hand tracking and, more recently, tongue tracking. Hand tracking in VR. Hand tracking in VR allows users to interact with the virtual environment using their natural hand movements, without the need for physical controllers. This enhances the sense of immersion and eliminates the need for external devices, providing a more intuitive and freeing experience. Hand tracking technology relies on sensors and cameras embedded in the VR headset to capture and interpret the user's hand movements. Introducing tongue tracking. Tongue tracking takes the concept of natural interaction in VR to a new level by incorporating the movements of the user's tongue. The idea behind this technology is to capture and translate tongue movements into virtual actions, adding a new dimension to user input. While hand tracking primarily focuses on replicating hand and finger movements, tongue tracking aims to bring facial expressions and nuanced interactions into the virtual space. Technology behind tongue tracking. Tongue tracking technology likely involves the use of advanced sensors and cameras integrated into the VR headset. These sensors can detect and interpret the subtle movements of the user's tongue, translating them into corresponding actions within the virtual environment. The accuracy and responsiveness of tongue tracking depend on the sophistication of the sensors and the underlying algorithms that process the captured data. Applications of tongue tracking in VR. Enhanced communication and expression. Tongue tracking can enable users to express themselves more naturally in virtual social interactions. Facial expressions, including tongue movements, contribute to the richness of communication. Fine-tuned control. Tongue tracking may provide a finer level of control for certain interactions within VR applications. This could be particularly useful in precision tasks or activities that require delicate movements. Immersive gameplay. In gaming applications, tongue tracking can introduce new gameplay mechanics. For example, controlling a character's facial expressions or performing in-game actions using tongue movements can enhance the gaming experience. Accessibility features. Tongue tracking might offer additional options for users with physical disabilities, providing alternative input methods that cater to a broader range of abilities. Challenges and considerations. Accuracy and calibration. Achieving accurate tongue tracking poses technical challenges. Calibration processes may be required to ensure that the system accurately interprets individual users' tongue movements. User comfort. Tongue tracking introduces a new level of intimacy in user interaction. Ensuring that users feel comfortable and not self-conscious about their natural facial expressions is crucial for widespread adoption. Privacy concerns. As with any technology that involves capturing facial movements, privacy concerns may arise. Developers need to implement robust privacy features to address potential worries about data collection and usage. Integration with existing VR ecosystem. The successful adoption of tongue tracking depends on its seamless integration with existing VR applications and ecosystems. Developers may need to update their software to take full advantage of this new input method. Future implications. The introduction of tongue tracking in VR represents a step forward in the quest for more immersive and natural interactions within virtual environments. As technology continues to advance, it's likely that VR systems will incorporate a combination of input methods, allowing users to choose the most intuitive and comfortable ways to interact with the digital world. Conclusion. In conclusion, the integration of tongue tracking in the Quest Pro or similar VR headsets reflects the ongoing innovation in virtual reality technology. By expanding input options to include facial expressions and nuanced movements, developers aim to create a more immersive and intuitive VR experience. As with any emerging technology, the success of tongue tracking will depend on its practical applications, user acceptance, and continuous refinement of the underlying technology. As the VR landscape evolves, we can expect further advancements that will continue to push the boundaries of what is possible in virtual reality.